Hi guys, today I wanted to make a short video on a very useful bit of software called Boardviewer. This is a program that is a great assistance to you, especially if you want to repair laptop and desktop motherboards, graphics cards and such like. It would work really anything you can find a Boardview for, but in particular motherboards and graphics cards, which I use this program for. So Boardviewer is basically a bit like having a schematic diagram, but it doesn't present the information in the same way that a schematic or circuit diagram does. In some ways, a schematic diagram is better, but in other ways, the Boardviewer is better, and particularly for motherboards, I find the Boardviewer is probably the preferable way of working for me. If I can find both the schematic and the Boardview, I would most likely use a Boardview. Some manufacturers seem to produce one and some others, so you'll often find that Asus, ASRock and some other manufacturers, you'll find Boardviews, and then for Gigabyte, MSI and maybe other ones, you'll find schematics. So it tends to be like a one or the other. But anyway, today I want to have a chat to you about Boardview, and it's my favourite bit of software really for diagnosing faults. So this is the website. It's boardviewer.net. It's a very small download from here, so we'll just download. I'll just put it into the last folder I was sticking downloads in, save it into there. It's a very small download, and it's already that. It's 1.1 meg. Yeah. This works as it says here on Windows operating system of XP and newer. I'm using on Windows 7 here. It works on Windows 10. I've tried it on there. There's a few requirements. This Net Framework you need to install. Microsoft Net Framework. It won't work without that. You've probably got that installed anyway. Otherwise, that's another free download from Microsoft. It's a lot bigger than 1.1 meg though. So this sort of shows you what Boardview is going to look like. We've downloaded it, so let's go into the folder. It's here, downloader. It's just a zip file, yeah. So we'll just extract that. This is Boardviewer, and as you see, there's no installation required. You click on it, it runs. It's just a portable executable. You can keep this on a USB stick or whatever, yeah. So this is Boardviewer. Very simple. File, open and exit. View. I'll just leave all these there. You can flip the board horizontally and vertically. I'll show you that. Options, nothing really. English or Russian? Yeah, I don't have English. Help takes you to the about, but it only tells you where to download it from, which you already knew. There's no manual I can find for this. There's no manual information on the Boardviewer website, but it's a very intuitive program and quite simple to work. So first thing we're going to do is open a file. Yeah, file open. This is a file I've opened recently. It's an ASRock Z87 Extreme revision 4, Extreme 4 revision 1. So we open the file, and there you can see basically is a picture of our board. Yeah, I'm using the mouse scroll button to zoom in and out. I can use the left button and basically grab this and move it around. So it's extremely intuitive to use. So there's our motherboard. If you're using this, I'm sure you're going to be using this because you've got the motherboard yourself on the desk and you want to look at this while you're working on the board. And I'm sure in later videos we'll definitely be doing that while we're repairing stuff. So obviously you could turn the board around so it matches what you see on the screen. Or the other option is just to go to here to view and flip the board horizontally and vertically. Strangely enough, to me, these are the wrong way around. If I flip it horizontally, I'd expect the processor socket to go to this side. But what actually happens is it flicks upside down. So horizontally basically seems to me flip it vertically. And vertically flips it horizontally. But however you want to look at it, that's how it works. It's quite simple, yeah. So this is a board view. How do we use it? Well, let's have a nosy around this motherboard. It doesn't really matter which way up we have it, but these are the power connectors, so let's stick them at the top, yeah? Let's go the other way. You'll soon get used to flicking these horizontally when you want it to switch vertically. Let's see if we can find some component that's a common thing to find. An SIO, there'll be an SIO on here somewhere, probably over here. So as I'm hovering the mouse over the part, you'll see it's telling me, and that's saying it's an NCT677D Nuvoton, which I know is an SIO chip. So we can zoom in on that. There's an SIO chip, yeah. If we click on the chip, once left mouse button, look, it's come up here down now. It's listed all the pins. It's given us the part number, and it's listed all the pins, and effectively given names to them like VCore offset. Some names more meaningful than others, yeah. Power OK, O power OK, hard drive LED, yeah. Power fan in. So he's giving us some information. The main use of this is of the maximum benefit if you also have the datasheet for the component. But if you don't have the datasheet, this can tell you quite a bit about what you have going on around things. So if we click on one of these pins, PCI reset, you notice there's that little drop down box saying PCI reset hash. The hash means that signal is low, so when that signal is low, PCIe is reset. So let's click on that, yeah? That's shown as the pin here, PCIe reset low. If we zoom out, you'll notice the one I clicked on, that's now in red, yeah? It also gives us the name up here and the part number. If I zoom out now, this should show us where that pin is actually connected to in yellow. See over here? PCI reset. And this is a resistor, yeah? It's telling us, in fact we can click on it. Let's click on it. It's a resistor. Telling you the value is 0 ohms. This is a great way of finding the value of components because generally the surface mount components have no markings on them. It's telling us a 0 ohm 16th watt, giving us some information on that, yeah? And it's telling us what's on this pin. And the other pin we can go to, look, it goes to the power good signal on the reset slot, on the PCI slot, yeah? So you can see PCI resets coming in here, and it's going out there. You can also see PCI resets coming in over here. This will be another resistor, and it's telling us where the other pin goes to. 3 volts. That's like a pull-up voltage. But you'll often find there's resistors on signals. One end's going to 3 volts, and the other end is a signal. So generally, the chip will drive that signal low. When the chip stops driving the signal low, it will just float to whatever voltage. So these resistors used to pull it back up to 3 volts to give you a definite 3.3 or 3 rather, or 0 and 0, yeah? So we can follow these signals around the board quite happily like that. Let's have a look elsewhere. What's this long thin thing? It's the battery. It's the CMOS battery, and it's telling us there's 2 pins. Pin 2 goes to ground, which goes pretty much everywhere on the board as you'd expect, all those yellow dots, yeah. And the other pin is battery plus. And we can see on the board where that goes to. Now, you can see it goes to a resistor here, yeah. So again, you can click on the resistor, it'll tell you here, and it'll tell you what the other pin is. So effectively where that pin goes to. It goes to this little thing here, which tells me is Schottky. Gives me a part number, BAS40CW. Schottky is a type of diode. So again, we can click on that, and it's effectively showing us where that signal is going to. And we can, again, follow around the board and see where the signal actually eventually ends up, yeah? You can see it goes all over the place to here, yeah? So, that's really how you use Boardview. There's no more complicated than that. I'll show you a third example. Let's go to something we can recognise. This is your CPU socket. Yeah, I'm sure you can see that's a CPU socket. And around it, these are your inductors, your inductor coils, yeah? Your phases. And if I'm just hovering the mouse over it, I can see this is an inductor coil, and it'll probably tell you, this one says, look, it says 1, a phase 3, a signal name, and 2 is VCore. This one isn't. Oh yes, this is VCore. This is VCore 1 and 2. So these we all know are all on VCore on different phases. Phase 4, yeah, phase 4, and they're in whatever order they are. Phase 2, phase 2, phase 5, phase 5. So let's look at VCore. this pin here I've clicked on, it's telling me here is VCore, yeah? It's giving the value of the inductor, which might be very, very useful to know. And it's telling us what's on there. So it's got VCore on this end, and the other end it's telling us to the right, this is L6625 phase 4. So we click on that one. Let's click on that one. Now you can see there's two inductors here on this phase, yeah? Phase 4, phase 4. And there's two sets of FETs. And we've looked at these before, haven't we? Look, you can see one end of this FET and 3 pins, so this is like drain and source, or source and drain, are connecting to that coil. Yeah? Look, this has gone red now, I've clicked on it. These are yellow, shows you where it's connecting to. In fact, it will even tell us that this, let's click onto the FET. The part number of the MOSFET, yeah? It's telling us there the part number of the MOSFET and the pins, where they go to, yeah? You'll also notice that we have another option that says net, yeah? That lists all the places that phase 4 goes to on the board. And if you want to see where else it goes, you can just click on these names as well, and it'll show you where it is, yeah? Although I often find just having the red and the yellow on the board is a way to go. But anyway, let's go back to our one of our FETs, yeah? We've talked about buck regulators before, so we know that one of these is connecting to 12 volts. There, look, 12 volts. It says on the floating little box, 12 volts. Yeah. This end here is connecting to the other one there and connecting to the coil. That's the junction between the two, and then the other end of this one will be going to ground, and it's showing us that. It's telling us on the floating box it's ground. Go back to part on here. It's telling us it's ground. Yeah. Let's have a look where the gates go to. So let's go on one of the gates. Well, the gate goes to this resistor. Yeah? Showing you that. And goes to the other end of the resistor, and it goes to the other resistor. So these two resistors are connecting together, and this one, I was probably going to the gate of the other one. No, it didn't actually. Yes, it did. Gate there. So that takes us so far, but okay, so we know what's driving the gate on this, yeah? Where's it come from? Well, we can zoom out, and now you can see there's a yellow and there's a red. So we know the gate drives there. We know it must come from somewhere. The VRM controller, we can assume, but we can't see it going anywhere. Look, I'm zoomed in there, yeah? Everywhere I go around on this board, I have to zoom it out a little bit. Everywhere I look on this board, I cannot see where that's going to. Yeah? Nothing else is in yellow. But we know it must go somewhere. The gate driver's got to come from somewhere, yeah? So we can go to this side, look. This shows us the part, resistor 1 ohm, yeah? And the other end, that end is actually, look, it's on yellow, that's the FET, yeah? This will be something like low gate, and then you'll have a H gate for the high side, this is the low side. And the signal comes from here, but where does it go to? You notice on here net it says 3 places, yeah, and we can only see 2, one there and one there, but net says there's 3. So let's click on net. We can see the ends of the resistors, 1, 2, we can see they changing to red, and the other one's going to yellow. Where's the third one? Ah, it's there. Look, it's underneath the board. This is the opposite side. These are the capacitors you see under the CPU socket, and there's some components on this board on the other side. That's where it goes to. Okay, let's go to the chip. This will be a MOSFET driver. We say MOS drivers, give us a part number, yeah? Let's click on that. Go to part. Let's have a look at this. Right, we can see the various pins on this, yeah? So we can see lower gate 4, upper gate 4, pulse width modulation 4. If you've learned a bit about these circuits, and I'll certainly teach you about this, the pulse width modulation is the input, yeah? So VCC will be power pins, but let's go to pulse width modulation. Pin 3 on the chip. Doesn't go to anywhere else on this side, yeah? But net says 2. Okay, click on net, click to there. That's where it comes from. The controller. As we said when we started, we knew somehow that these VCore drivers, the MOSFETs, were connecting somehow to the controller. Now, not do we only know how they connect somehow, we actually know how they connect. This is the controller. And pin 33, well, let's see what it is. It's saying pulse width modulation controller, yeah? Part. It's there. So this is the part. Pin 33. And here we can see now, we pulse width modulation 5, 2, 4, 1, 3, 6. So we can see all the different phases, yeah? We can see the output voltage regulator ready. It comes out of there. Let's say this isn't working. We've got no drive, and we can't find a data sheet for it. Okay, what can this tell us? Well, it'll certainly tell us where there's 12 volts on it. It tells you which pins are ground. Yeah, VCC, that'll be a power pin. So we can have a look to see whether there's any power on this chip. What else can we do? We've got a reset pin, which is when there's no hash, so if that's high, it's got a reset. So we could check there. And if you don't want to probe on the chip, have a look around you. Look, you found a resistor. It's easier to get your probe on here than it is on there. So we'll go to there, make life easy for yourself. Is there something that says enable? That'd be useful. Yeah, VCore EN. That is almost certainly an enable pin. There it is on the chip, and you can see that enable goes to a whole load of resistors, and it also goes to this MOSFET, yeah? So we can start tracing things back now. We know where the enable is. We know EN doesn't have a hash, so it should be high to be enabled. So say this is low, we can come here, we can measure, oh yeah, look, it's low, it should be high. We can see where it comes from now. We can go on this chip here. There's an output enable here, there's a gate. There's VCore enable, that's the one that goes out. And we can see now which are the gates. There's another enable here. We can probably find a data sheet for a MOSFET. And I'd say this is probably a dual MOSFET. It's got 2 gates, Luke. And from there, again, we can start working the back. We can start to find out where this enable signal comes from. Click on the signal. Yeah, it goes off over here. Yeah, to another MOSFET OTP enable. And again, from here, we know where to probe, and we can effectively go and chase that around the board. So that's how Boardviewer works. It's a very simple program. The information you'll get from Boardviewer will increase with your knowledge of motherboards. Again, I'll hope to lots of tutorials on it for motherboard repair, and as you see me using this, your knowledge will increase. It's a great tool for having a look around, for sure, and it's a good way to try and figure out, even if you have a working board, you know, go have a look around and see where signals come from. Another great use for this is for BGA chips. This is a PCH, yeah, where obviously these connections are underneath the chip, and you can't get a meter probe on them if you're interested in them. But if you click on the connections, you'll often find, look, in this case, this connection here, SATA LED low. See the little hash bars? That signal is low active, yeah? SATA LED low. And although you can't probe that, you can probe this component here. This is where it goes to. The other end's going to 3 volts. In fact, you can probably see this. This end will have 3 volts on all the time, yeah? This signal is active low. It's got a hash on it, yeah? SATA LED hash. And this is just a pull-up resistor. So, effectively, when this chip, the PCH, wants to turn the SATA LED on, it drives this low, yeah? When it wants to turn it off, or vice versa, it just stops driving this pin. It doesn't pull it back high. This resistor pulls it high. And that's one of the good things about this, that you can actually see where things connect to. You can also click on the pin and go to net as well. And it was already telling it's going to a resistor. Again, this one's on the other side of the board. But we know that we can, if we want to probe that particular signal, we can do it here. We can get a meter on it. Okay, guys, so that is Boardview. That is Boardview and how it works. I hope you find that a useful tutorial, and I hope you start using Boardview. I'll be using Boardview. It's a fantastic program, and it's completely free. I also did another video on here called Online Resources, which I'll link in the description to this one, which explains where you can actually find board views. You won't find them for everything, but you'll find hundreds, probably thousands of them on the net. So also look at that link to find out where to find some files to view. Okay guys, hope you enjoyed that, and I'll see you on the next one.